Today we're going to start a unit on similar figures. In today's lesson, we're going to talk about ratios, proportions, and then how they relate to similar figures. Let's start by talking about ratios. So a ratio compares two numbers by division. So for example, as a fraction, 1 and 4 would be the two numbers, and you're dividing them, 1 divided by 4. It can also be written as 1 colon 4, or written as 1 to 4. Now you always want to write ratios in simplest form. So if you have 7 to 14, 50 over 12, and 8 feet to 6 yards, we would need to simplify each of these. So 7 to 14 would be 1 to 2, 50 over 12 would be 25 over 6, and this last one here, we would want to make sure we have the same units to start before we actually simplify it. So 8 feet to 6 yards, I would simplify that to 8 feet to 18 feet, and then you can simplify that down to 4 to 9. Now, some examples of ratios that are found in geometry. Oftentimes, you'll compare distances. So, for example, if you have a number line here, and you're trying to compare the distance of AB to CD, you would want to write it as a ratio. So, from A to B, that's 3, and C to D, that's 2. So, AB over CD is equal to 3 over 2. You can also see ratios in geometry in an example like this, where you're trying to find angle measures. So you might be told that the angles of a triangle are in the ratio 1 to 6 to 13. Find the measures of all the angles. Now for something like this, you want to remember that because this is in simplified form, it doesn't mean that the angles of the triangle are 1, 6, and 13 degrees, but they are in that ratio. That means if I were to multiply each of those by a number, that could be the angles of the triangle. Now in this particular case, we know what the angles inside of a triangle have to add up to. So let's say you have a triangle here, 1x, 6x, and 13x. Because they're in that ratio 1 to 6 to 13, I can multiply each of those by some value x. Now I know that the sum of all of these should equal 180. So we have 1x plus 6x plus 13x equals 180. That gives me 20x equals 180, which means x equals 9. Now to find the measure of all the angles, I have to plug x equals 9 back in for each of these angles. So 1x would be 1 times 9, which is 9, 6x 6 times 9, which is 54, and then 13x is 13 times 9, which is 117. So the angle measures are 9 degrees, 54 degrees, and 117 degrees. You might also see examples of ratios if you're finding area and perimeter. So here's an example. It says the perimeter of a rectangle is 36 inches and the length and width are in the ratio of 4 to 5. Find the length and width of the rectangle. So I'm going to go ahead and start out by drawing a rectangle. Now since we know that the length and width are in the ratio of 4 to 5, it doesn't necessarily mean that it's 4 inches and 5 inches. It could be, but it might not be. So I'm going to call one side 4x and one side 5x. If I multiply by the same number for both the length and the width, I'm still going to be in that same ratio of 4 to 5, but I might be able to find the actual measurements based on other pieces of information, in this case the perimeter. Since the perimeter is equal to 2 times the length plus 2 times the width, now we can replace the length and the width with 5x and 4x. And since we're told that this is equal to 36, we can simply set this equal to 36. So this is 10x plus 8x equals 36. So we have 18x equals 36, and solving that, we get x equals 2. Now remember, this problem is asking you to find the length and the width of the rectangle, so we'll have to plug 2 back in for x. So the length is 5 times 2, which is 10, and then the width is 4 times 2, which is 8. So the answer to this is 10 inches and 8 inches. Next, let's talk about proportions. So a proportion is an equation stating that two ratios are equal. And solving proportions will involve using cross multiplication. So for example, if you have A over B equals C over D, this is equivalent to saying A times D is equal to B times C, and that will be the way that you'll want to solve the proportion. Now, some examples of proportions in geometry. One popular example would be scale models. So let's say you buy a 3D scale model of the Empire State Building. Now, the actual building is 1,472 feet tall, including the antenna, and 424 feet long. If the model of the building is 4 feet tall, then what is the length? Well, we can solve this using a proportion. So, I would say, in order to help you keep track of what you're putting where within the proportion, I would keep one side the scale model and one side the actual building. Now we have two pieces of information for the actual building. 1,472 feet tall and 424 feet in length. Now on the other side, I'm going to put the model. Now I need to make sure that I keep everything the same. So in the numerator on the left, that was how tall it was, and in the denominator, that was how long it was. So how tall over how long. So I'll do the same thing on the other side. So for the model of the building, it's 4 feet tall, so that goes in the numerator. And then we don't know how long it is. What is the length? That's x. Now I can cross multiply to solve for x. So we have 1,472 times x equals 4 times 424. And solving that, we get x is equal to 1.15. So the length of the model of the building is going to be 1.15 feet. Okay, so now let's talk about similar figures. Similar figures are figures that are the same shape, but not necessarily the same size. Now, the symbol that we use to indicate that two figures are similar is this squiggly, which we call a tilde. And so let's say here we have two triangles and they are similar to each other. We would write that ABC is similar to DEF. Because all the sides are equal in triangle ABC and all the sides are equal in triangle DEF, it doesn't matter the order. However, you do want to write your similarity statement in the same way that you wrote congruent statements. So you want to have corresponding parts in the same order. So angle A should correspond to angle D, or side BC should correspond with side EF. Now they won't be congruent here, but you should know which side of the triangle corresponds to which side of the second triangle. Okay, now we can also work with similar polygons. In similar polygons, corresponding angles are congruent and corresponding sides are in proportion. So now we're extending this beyond just triangles. We're saying for any polygon that's similar, that means it has the same shape, but not the same size. So in any of these similar polygons, corresponding angles are congruent and corresponding sides are in proportion. So here we have ABCD similar to EFGH, and that is written in a very particular manner. This tells us that angle A is congruent to angle E, B with F, C with G, and D with H. And then we also know that the corresponding sides are in proportion. That means AB is in proportion to EF, BC in proportion to FG, CD with GH, and DA with HE. In this particular case, they're all in that ratio of 1 to 2. Take a look at example 1. Are these figures similar? If yes, write a similarity statement, and then list the proportional sides. Okay, how do we know whether or not they're similar? Well, if you actually just look at all the angle measures, you'll see here that we have a right angle, B, and a right angle, G. We also have angle C with 59 degrees and angle H also at 59 degrees, which must mean that angle A and angle J must be the same as well. So, since all three angles are congruent, now we just have to see are all the sides in proportion. It looks like if we take half of each of the sides in triangle ABC, we actually end up with the sides in GHJ. So we have side 10 there, divided by 2, we get 5. We have side 6, divide that by 2, we get 3. And 11.6 divided by 2, and we get 5.8. So for our similarity statement, we would want to write ABC is similar to JGH. Now we want to list the proportional sides. So AB with JG, right, 10 to 5, which is 2 to 1. And then BC to GH, and then AC to JH. And in each of these, if we were to simplify, we get 2 to 1 for our ratio. All right, take a look at example 2. Are these triangles similar? Again, if yes, write a similarity statement and determine the similarity ratio. So it looks like we have angle L congruent to angle P. We have a right angle at M and a right angle at N. So that must mean that angles J and S are also equal to each other. Now if we look at the sides, we want to see if they are in proportion. So we want to see 75 over 30, the hypotenuse of each, and then check 60 over 24, and then check 45 over 18. And they are all, in fact, in the same ratio of 2.5. So yes, they are similar because all three angles are congruent and all the sides are in proportion. So our similarity statement would be JLM is similar to SPN. From there, we can write our proportional sides. So JL over SP, LM over PN, and JM over SN. So that first one would be 75 over 30. Next would be 60 over 24. And the last one would be 45 over 18. And simplifying each of those, we get 5/2 each time. Okay, our last example. If ABCD is similar to EFGH, find the value of x. So let's start by writing a proportion. So I'm going to keep it the same. I'm going to look at AB, which corresponds with EF. So I'm going to write AB over EF equals, and then BC corresponds with FG. So notice how I'm using all the sides that were given to me, AB, BC, EF, and FG. Then I kept it to be the same corresponding parts, so AB with EF, and then for the second ratio, I again started with the rectangle on the left, so BC, and BC corresponds with FG. Now we're going to go ahead and substitute for each of these. So we have 4 over x plus 3 equals 3 over 2x minus 4. From here we can cross multiply, and we have 4 times 2x minus 4 equals 3 times x plus 3. And we can simplify, and we end up with 8x minus 16 equals 3x plus 9. Move 3x over to the left, add 16 to the right, and we end up with 5x equals 25, which means that x equals 5. And this is just asking you to find the value of x, which we did. If you wanted to double check, you can plug 5 in for x, and we would have EF is equal to 8, and FG is equal to 6, and you can see that the ratio from ABCD to EFGH is 1 to 2.